What's up, Code Squad? I hope you enjoyed the last episode where we worked on basic teleoperated controls while driving. And we're going to be expanding on that a little bit in this video, where we're going to be talking about button mapping and using buttons on your controller to execute certain commands that your robot would need in the teleoperated section. We will also be talking about object-oriented programming, so it's going to be a little bit of a longer video. And without further ado, let's get started. Up to this point, we have done everything in robot.java. And while this is okay for demonstration purposes, it's going to be harder to manage once you actually start incorporating different programs and trying to execute different commands and really trying to build your code so that your robot is competition ready. So from this point on, we're going to be working with object-oriented programming. And this is going to make it a lot easier to use the tools that First is giving you. It's going to be much easier to troubleshoot, and it has a lot more benefits than just writing everything into robot.java. So there are four parts really to this object-oriented programming for FRC, and that is subsystems, commands, the OI, and the robot map. So once we get all of this stuff down, after that, you're going to have a very good basis of how to use these different tools in order to make your own code. So let's just go over first what each one of these things do. So here we have basically a subsystem, which is it defines certain mechanisms for the robot and provides basic functions on how to manipulate them. So it's very simple and very easily usable by different commands. And that brings us to the next thing. So a command uses the subsystems method to periodically execute a certain task. And we're going to touch on this as well. The OI is kind of your button map. It's how you can take the controls from your button and make them into commands and have them run commands. And finally, the robot.java connects to the OI in order to run the whole program. So this is kind of, and then main here, it just basically starts the robot and goes to robot.java. So we don't really need to care about the main. And that's basically the skeleton of it. The robot needs the OI in order to run just controller-based commands. The OI needs actual commands, and commands need subsystems. So let's create a program where you will need to click on one of your buttons in order to, let's just say, move forward for 5 seconds. So how would we start this? Well, we would start it in a subsystem. So here we have an example subsystem.java, and let's just take this out, just copy, paste it, and then let's rename it to tankdrive, tankdrive.java. So here tankdrive.java is basically going to consist of basic move functions that you will need throughout the code. So let's go here and let's start. First, since we renamed it to tankdrive.java, we're going to also have to rename example subsystem to tankdrive as well, just to make sure that everything's good. Next, we already have all of this stuff, so all we need to do is just copy and paste from the robot. Let's get our vectors right here and copy and paste them. And let's put them into the tankdrive subsystem because we're going to be calling upon it here. Now, it's going to give us a bunch of errors, and that's because we haven't imported the Victor SPX yet. In order to do this, it's really simple. Just control period, and then just click import Victor SPX. So there's going to be a lot of numbers. It's going to be very difficult to, as you have more and more variables like these, you don't really want any loose numbers, any numbers that go unchecked. So what our team does is we use the robot map here to store all of our different kind of constants that we use. So let's just call this one robot map, in order to declare it, robot map dot, and then let's call it front. And front, what did we call? We said that this was left in our last video. So let's just call it front left. And of course, it might be different on your robot. This is just kind of how we're doing it on the imaginary robot. So it's gonna say robot map. We have to import robot map, and then it's gonna give us an error because there is no actual variable called front left. So we're gonna go here and we're gonna say create constant front left in type robot map. We're gonna go here now, and it's set it automatically to 0. We just want to change that to 20. And let's just change this for all of them. So we have front right, and then we have back left, and then we have back right. So we also want to change their variables to 21, 22, 23. Basically what we're doing is we're just matching the same ones here, but now instead of just being a flying number, now we have an idea of what it is. It's actually just the front right motor, or robot map dot front back left motor, and then robot map dot back right motor. And while it seems kind of trivial to do it on these kinds of things where it's only one variable and it's a pretty easy variable to remember, it's a good habit to just keep on doing this as you go forward and code much more complicated things. So now that we have this, we can start just writing different methods here. Let's ignore this for now, the init default command. And let's just have a move function. So we want our left and right wheels to be moving in different, we want our left and right wheels to be able to move in different speeds. So what that means is we're gonna have public static move, and then we're gonna have double left and then double right speed. So right now what this means is we're creating a move function here that can be imported, and it can be used by other command subsystems robots, and all it does is it takes a speed for the left wheels and a speed for the right wheels. And now all we have to do, and we already have this here, just go to robot and just command C and then just command V. So very easy stuff, and then just import all of the different things using the trick, just control plus, and now everything's good. Now we have a basic move function. There's an error here, and of course, yes, the return type, public static void move. So now what we can do is we can actually just simplify this in robot and just say, go over here, and let's just call it tank drive dot move left and right. And so now our code is much simpler, and we're beginning the object-oriented programming we are actually inheriting from tank drive. And of course, there's it imports the subsystem tank drive as well right there. So now what we wanted to do was make a command. So let's just go right here, and right here, let's just copy and paste this. So copy, paste, and we're gonna try to make the robot go forward for 5 seconds, and then just go forward for 5 seconds for now. So let's go here and let's call it go for 5 seconds. Alright, so this is kind of our command that we're giving it. It's not very well worded, but it'll work for now. So go for 5 seconds right here as well, and go for 5 seconds. Here, the requires is declaring the subsystem dependency. So what we're going to have here is just say requires, and here it's calling upon the robot. So what we will have to do is create a subsystem of the tank drive. So what does that mean? We're going to go here and let's create a new kind of like chunk for it, and then say public static tank drive is equal to new tank drive. And basically what this does is public static tank drive, and let's just call it tank, or tank drive. And now, as you can see here, it had the public static example subsystem is equal to new example subsystem. We can basically call upon this as a dependency, and now the robot knows that it has an understanding that, okay, this is the dependency that we're talking about whenever it's using the command. So we're just going to go here and say robot.tankDrive. And another reason why you want to do this is because just to prevent any mechanisms from breaking, when you require something, you only have it do one thing at a time for one subsystem. So it makes sure that two things that are going to be using the same machines or motors will not be working at the same time. That would like kind of give damage to the motors. So now that we've declared our subsystem dependency, let's look at the rest of this command. We have initialize, execute, is finished, end, and interrupted. So we're not going to be looking at interrupted, we're just going to be doing the rest of these. So initialize is what happens when the command is first started. So if we're going to go for 5 seconds, when we initialize, we have to get the start time. So let's go here and let's declare a variable. So public static start time, and then just have it here, and then we're going to declare it in the initialize. So we're going to say, oh, we forgot to write double. That's my bad. And then we're just going to say start time is equal to timer dot get FPGA stamp. So basically, whenever the command is called, it gets the start time. That's all we need to know. And now this command runs periodically every 0.02 seconds, and it just runs this execute code. So whatever you really want inside of that block, you just put it there, and it's just going to be repeating. So what we want to do is we want to say, okay, we want our robot or a robot to move forward, and let's just say tank drive. In order to call on the move function, tank drive dot move, and then let's say that both of the left motors and the right motors are facing in the right direction. It would just be 1 1, and there you go. So now we would need to, of course, import by clicking Control plus, and so now every 0.02 seconds, it's going to be just what's it called? It's just going to be moving forward. Now, this is going to go on forever because we aren't actually ending it at any point. And my team, we had one problem where we were just like, if it just kept on going, the motor, and we were just like, what's happening? And it turns out that we fell victim to the same problem. So always check to see. This is a very simple problem to fix, and it's a really easy problem to miss, and it can take up a lot of time. I remember in our team's circumstance, it took like four hours to actually to catch this error. So don't do what we did. That's kind of why this is like kind of a PSA, so you guys don't have to follow in our footsteps in a negative direction. So let's go back to here, and basically what we have here is finished, and what this does is it's right now it just returns a Boolean, and what happens is right here with the end is called once after is finished returns true. So basically what we're doing here is saying, okay, if it's finished, then we're going to return false, and then if it's not finished, we're going to return false, and if it is finished, then once we return true, then this ending code is going to run. And now, of course, when we end it, we want both all the motor speeds to be 0. So we're going to say tankDrive.move 0 0, setting all motors speeds to 0. Here, Now let's, for the execute, well, first, before we do that, let's create a boolean for is finished. And what we will do is we'll just say return time passed. So basically, whenever time passes, it's going to switch from false to true. And we're going to create a new instance variable here, public static boolean, and then time passed. And let's initialize it as false. So in our execute, we're going to be, and you can do this a lot of different ways. I like to have it so that it's all in the execute, but it's basically saying if timer dot get fpgi stamp. So here I'm going to put tank drive here so that it's not too much red. Okay, so if the current time basically minus the start time is less than 5, so if there hasn't been 5 seconds that have passed since the beginning of the command, we're going to be moving forward. Else, so this is where we're going to be changing. So now once it has moved for 5 seconds, we're going to say else, and then we're going to go here and we're going to set time passed equals true. And then once we set time passed equals to true, then it's going to be returning true for is finished, and then once it returns true for is finished, then it's going to end the command. So now we have this command, we have the subsystem, but we're not actually calling upon it. And what we're going to have to do there is we're going to have to go right here into the OI, and we're just going to have to create a button. So they actually have some code that we can use here for us, so we'll just have that right now. And let's go here. So what we will be doing is first initializing our joystick. Now our joystick right here is just the public static Xbox controller, drive controller. So we're just going to copy and paste this, and then just put it where the OI is. Now, of course, this 0 is not good right now because you don't know where 0 could be. 0 could mean a lot of different things as you're working, and it's always good to just put it in the robot map. So just robot map dot Xbox port. And so we're gonna go here, and then let's first actually import Xbox controller, and then we're gonna go here and say create constant in type robot map. So robot map automatically defaults to Xbox port being equal to 0. And now what we have to do is create a new button that takes from this drive controller. So we're gonna say public static button, and we're gonna import button is equal to new joystick button drive controller, and then button number. So you can have a lot of different buttons. And then here, all right. So while we're initializing the button, all we need to do right now is let's import joystick button, and so we have initialized where it's going to be on which controller it has to look for. All we have to do is have the button number. So we're going to be using the green button on the controller, and let's just go here and say robot map dot green button. And for our team, with our controller, its green button is 1, and it is for the controllers that FRC gives. So we're gonna go here, public static final integer green button equals 1, and once we have that, we're basically set. So we have created the button now, and all we have to do is call upon it. So when we go here, and let's just call it move button, so that it's not too vague. And all we have to do now is just say, let's go down, move button dot when pressed, and all we need to do is just say new, and then let's go here, new, go for 5 seconds. And that's our command. So now, let's say that and of course, always remember to put your parentheses. And for some reason, it's not working, which is pretty nice. So why is it not working? Move button, new, go for 5 seconds. So this is not it. So I'm back. What we forgot to do was just have here public. These are instance variables. We forgot to put them in an actual just class. So public OI, and then we're gonna go here and just put the move button dot when pressed right into here. And now it doesn't see the go for 5 seconds, so we have to just import it, and now everything is good. When we call on this, when we press this button on the drive controller, it will run this command. So let's say now this is just one last thing that I want to touch on, and that's making your commands reusable. So let's say we wanted to have 2 commands, one where you go for 5 seconds and one where you go for 3 seconds. So how would we do this? How would we put this into one? Well, what we would do is we would just say, let's say, go for seconds. Rename it, go for seconds. And what we would have to do here is pass in a parameter. So let's just say double seconds. Now, what this is going to do, and we can have our public static boolean. Let's just say seconds is equal to, and then we're just going to have this, and then when we declare it, we're just going to say this dot seconds is equal to seconds. And this right here is calling upon what's it called? This right here is going double seconds. Oh, sorry, it's not a boolean, it's double. All right. So for some reason it's giving me an error. All right, let's just make it non-static. So now this is giving us seconds. Our instance variable seconds is equal to double seconds here. If I go here and just say seconds and like abbreviate it, it's gonna still do the same thing. So we're gonna have some errors, but we're gonna ignore those for now. And we're, instead of just going for 5 seconds, we're just gonna name this to sec. And that's just gonna be the parameter passed through for go for seconds. Here, we're just going to rename this to go for seconds. And then, let's say for this one, we just want to have it go 5. Let's just import this. And we can delete this one. And then afterwards, let's just have another one where we have move button. Or not move button, let's create another button. So public static button. And let's just call this one move 3 seconds is equal to new joystick button, drive controller, and then I will have to check the GitHub for 1 second. So this is our team's GitHub, and here you can see our robot map right here, and there's a lot of different values that we have, but let's go right here, and we need the button green, so red button right here, and the red button is robot map dot red button. When it's equal to 2, so when we initialize it, we create the constant, we go here in the robot map and we just set it equal to 2. Very easy stuff. Once you get the hang of it, it's really easy. And you can really use this, just use the strategy for all different types of commands and subsystems that as you wish to execute what your team needs. So move 3 seconds dot when pressed, and then we're just say new go for seconds, and then just call it 3. And yeah, that's basically all I have to talk about with this lesson. I hope to see you guys later, and I hope you enjoyed. Thank you.